This lecture video is about modeling with linear functions. The first problem that we have here to work on, we have a fruit company recently released a new applesauce. By the end of its first year, profits on this product amounted $30,000. The anticipated profit for the end of the fourth year is $66,000. The ratio of change in time to change in profit is constant. Let x be years and y be profit. First, we want to write a linear equation that relates profit and time. So in this particular word problem, they have given us a couple bits of information. They have told us that at the end of the first year, the profits would be $30,000, so that's 1 point on our line. And then they've also told us at the end of the fourth year, the profits will be $66,000, so that is another point that lies on our line. And we also know that it's a line because they've told us that the ratio of the change in time to the change in profit is constant, and that is the requirement that we have for a function to be considered a line or linear. And so now we want to write out this equation. The first thing that we need when we're writing the equation of a line is the slope, which is y2 minus y1 over x2 minus x1. And so let's just write out our points that they've given us. So the first point that they've given us is that at the end of the first year, so that means that x is 1, then our profits are going to be $30,000. So that's our first point. The second point is that at the end of the fourth year, so that's x equals 4, our profits will be $66,000, and so y is $66,000. So now we're going to calculate our slope. We're going to take 66,000 minus 30,000. And divide that by 4 minus 1. And 66,000 minus 30,000 is 36,000. And 4 minus 1 is 3. And so we have 12,000 for a slope. Now we're going to use the point-slope form, y minus y1 equals m times the quantity x minus x1, and we're going to write the equation of the line. So y minus, and you can pick whichever of these 2 points you want to use. I'll just always use the first point unless the other point is something a lot easier to use for some reason, but they're both about the same. So it's going to be y minus 30,000 equals 12,000, which was our slope, times the quantity x minus the x-coordinate, which was 1. Now we need to solve this for y, so I'm going to distribute my 12,000. That gives us y minus 30,000 equals 12,000x minus 12,000. And then we want to add the 30,000 to both sides. And that gives us y equals 12,000x plus 18,000. So there's the equation of our line. Now we want to use this equation to predict the company's profit at the end of the 7th year. The end of the 7th year means that x is equal to 7. So we're going to replace the x in this equation with 7 and calculate our profit y. So that's 12,000 times 7 plus 18,000. And 12,000 times 7 gives us 84,000 plus the 18,000 gives us 102,000. So the profit at the end of the 7th year should be 102,000. Oops, let me fix that too. Okay, and then and make sure that you answer your word problems with a sentence like that, and then predict when the profit should reach 126,000. So now they've given us profit, which is the y value. So this 126,000 is y, so we're going to replace the y with 126,000. So we get 126,000 equals 12,000 x plus 18,000. So to solve this, we're going to subtract the 18,000 from both sides. And again, we'll use our calculators here. So 126,000 minus 18,000 gives us 108,000 equals 12,000x. Last thing we need to do is divide both sides by 12,000. And we get x equals 9. So at the end of the 9th year, the profit should be 126,000. In this next one, we want to figure out what the slope is. So we've already know what the slope is. The slope is 12,000, and that's $12,000 per year. And then we want to describe what this means in the context of this problem. And so when you're doing this in the context of the problem, I always like to think of the slope as a fraction. So 12,000 over 1, and this is change in y, or profit, divided by change in x, which was years. So each year, the profit, and because this slope is positive, the profit is increasing, so the profit increases by $12,000. Okay. All right, so our next one here, in the year 2008, IBM had 398,500 employees worldwide. By 2010, the number had increased to 426,751. Let y be the number of IBM employees worldwide in the year x, where x equals 0 represents 2008. First, we want to write the linear equation that models the growth in the number of IBM employees worldwide in terms of the year x. So they've told us that x equals 0 represents 2008. So this is year 0. And so 2010 then would be year 2. So they've given us 2 points here. They've given us the point 2008, which is x equals 0, and 398,500. And they've also given us the point in 2010, which is x equals 2. The number of employees is going to be 426,751. So now we can write the equation of our line. The first thing that we need to do is calculate our slope, and that's y2 minus y1 divided by x2 minus x1. So we're going to take 426,751 minus 398,500 and divide that by 2 minus 0. Okay, so we're going to take 426,751 and subtract from that 398,500, and we get 28,251. And 2 minus 0 is 2. So now I need to divide that by 2. And so we get a slope of 14,125.5. And notice this point right here is a special point. This is our y-intercept. And so y equals mx plus b is just the slope and the intercept, and we have both of those pieces of information, so we can go ahead and write the equation of our line right away. 14,125.5x plus our y-intercept, which was 398,500. And so there's our equation of our line. Now we want to use this equation to predict the number of IBM employees worldwide in 2013. And so this is 5 years after 2008. So this represents x equals 5. So we're going to plug 5 in for x. That will give us y equals 14,125.5 times 5 plus 398,500. And do this on your calculator. So we already have the 14,125.5 in there. We need to multiply that by 5. That gives us 70,627. And we're going to add to that the 398,500. Which gives us 469,127.5. So in 2013, IBM should have 469,120, and we're talking about people here, so we can round that up to the nearest whole number, which would be 469,128 employees. In our next problem here, we want to know what the slope is and what does it mean in the context of our problem. And so our slope this time was 14,125.5, and this is employees per year. And again, I like to think of this as a slope, and this is employees and this is the years. So each year, the number of IBM employees worldwide will increase by 14,125.5. Okay, and then one more problem that I just want to add on here, and that's what is the y-intercept? And what does it mean in the context of this problem? So first of all, say what the y-intercept is. So the y-intercept was 398,500. And what does it mean in the context of this problem? It means in 2008, the number of IBM employees, is the 398,500. Okay, so that ends our lecture on modeling with linear functions. Let me know if you have any questions. Thanks.